Hello everyone, myself Arshini. I am a final year engineering student in Wheeltech Multitech Dr. Rangarajan Dr. Samutala Engineering College, studying in the stream of Electronics and Communication Engineering. So I am here to present my final year project, which is titled as Gesture Controlled Robotic Arm Integrated with the Drone. So before starting, I would like to thank Almighty and my dear staffs for offering me support and guidance throughout my project. So let's go to the topic. Gesture control robotic arm integrated with the drone. So as this name suggests, you can easily understand that a gesture control robotic arm is integrated with the drone. So basically, when we talk about drones, we will be thinking about the flying robots. So there are many kinds of drones available in this market, which includes aerial drones, underwater drones, and amphibious drones, etc. So, aerial drones are the drones which use air as the medium to travel, and underwater drones are the drones which use water as the medium to travel, and amphibious drones are the drones which either use air or water for the mode of transport. So, in this project, I have integrated both the gesture control robotic arm along with the drone. We can even call the drones as the flying robots, which uses propellers to fly into the air. So throughout this PPT, we'll be seeing the objective, introduction, literature survey, inference, proposed work, flow of work, hardware requirements, software requirements, component specification, principle of working, results and discussion, and conclusion, etc. So let's go to the topic. At first, we can see the objective of my project. So the objective of my project is to make use of drones and robotics to avoid the involvement of humans in the hazardous operations. So sometimes in many situations, the humans are forced to work in very hazardous and harmful environments, and they are forced to do tasks which are unhealthy for their own self. So in that kind of situations, we can make use of this project in order to avoid and in order to safeguard the humans from that harmness. So the main objective is to enhance safety, productivity, and also precision by developing the drones which is integrated along with the gesture control robotic arm. So we can employ this project in higher altitudes, even though this project is working in a higher altitude. We can easily control the drone as well as the arm remotely, which will be in some part of the ground. So we can also expand the human reach to conduct research and rescue missions in remote or inaccessible areas, improving the whole response. So there will be situations in which the human reach can be very less. So in that kind of situations, we can make use of these drones. We can make the drone fly to that affected area, and with the help of the gesture controlled arm, we can easily control, and we can with the help of cameras integrated with the drone, we can monitor what are the scenarios happening in that higher altitude places, and we can easily control and make the task possible from the ground by just controlling the robotic hand from using our gestures. So next slide. Introduction. So in this project, I have integrated the gesture controlled arm in the aerial drones. So as I said before, there are three types of drones available in this market, and one type of drone is the aerial drones, which uses the air as the medium to travel. So this is a flying drone, and here I have used the robotic arm, which is controlled using our gestures. So when we talk about robotic arm, there are many kind of arms available in the market, which includes articulated model and so on. And here I am using a humanoid model, which looks like our own hand, but it is controlled using our gestures. So the gesture control is achieved using flex sensors, which works like a variable resistor. So basically, a sensor is a device which senses the physical changes in the environment, and it converts it into an electrical signal. So this flex sensor responds to the bending of our hand. Uh, it it is achieved because of the change in resistance in that sensor. So that change in resistance is corresponded to the electrical value passed to the circuit. So the flight of the drone is controlled using the flight controller and electronic speed controllers, propellers, etc. And the gesture controlled arm is controlled using our gestures. uh, it is basically controlled using a glove which will be worn in our hands. So when we make a movement using that gloves in our hand, that movement is mimicked in the robotic arm. So basically the gesture control arm works works like a mimic of our own gestures. So these are the literatures I have gone through for this project. The first literature was robotic arm controlled by a robotic glove. So in this project, I'm using a gesture controlled robotic arm. So for that, this project will this project also speaks about the same thing, that is robotic arm control using a robotic glove. And the second is that a semi-wireless underwater drones with robotic arm. So in this concept, there is a it is kind of similar to my project, but the only difference is that it is an underwater drone, and the underwater drone is like kind of a crawling robot. It does not fly or anything. It just crawls, and it can explore the aquatic resources under the waters. So the next literature is the autonomous drone with robotic end effector for maintenance operation of 5G mobile towers. So in this project, it is also similar. The objective of this project is similar to my project. So I also made this project to work in higher altitude situations, which is same as the maintenance of mobile towers, 5G mobile towers. So the only difference is that here they have used the articulated model of the robotic arm, which is kind of like a pick and place robot, and the model of the hand is kind of different from my project. So these are the literatures available. So these are the inferences I got from the literature survey. From the previous work, it is inferred that the drone is either an underwater drone, which has limited usages. So the underwater drones can be applied into only a particular field, but when we talk about aerial drones, it can be employed in any kind of fields, like it can be useful in filmmaking, it can be used in agriculture, it can even be used in medicine, etc. The area of application for the aerial drones are very vast. On the other, the robotic arm used is the articulated model. As I said before, the articulated model is not a gesture controlled model. So in order to overcome the responsiveness and to increase the human interaction, we can use the gesture controlled arm. These are the inferences. So next, this is my proposed work. So in my work, I have integrated both the drone as well as the arm. So the dotted line denotes the So this dotted line denotes the boundary. That is this part. This part basically denotes the drone. This part basically denotes the drone, and this part uh, this part denotes the robotic arm, which will be this part is will be in the ground, and this part will be in the air. So here I have added the robotic arm to the drone. So here the black structure, you can see these are the parts of this black structures denotes the part of the drones, and this blue structure shows us the parts of the robotic arm. So this is the transmitter. Here this is the transmitter, and this is the receiver, and these are the parts which will be used in the robotic gloves. So basically I have used a flight controller board, a KK 2.1 flight controller. A flight controller is the heart of the drone. You can even call it as a brain of the drone. So it basically gives command to all other components attached to it. Here I have connected a battery, which is basically a power supply, and I have included a electronic speed controller, motor, propeller, etc. And it basically has this receiver which establishes the wireless communication between the transmitter on the ground to the receiver on the drone, and this robotic arm as a transceiver. The transceiver In a transceiver, it has both the transmitter and receiver. So here the in this the transceiver act as a receiving part, and here the transceiver act as a transmitting part. So we give commands using this glove into this robotic arm. So that is how that robotic arm works. So we can move to the next slide. So this is the flow of work. So before starting any project or any design, we must have the flow of work. So in this I made the study about the drones and also the robotic arms. So the first step in my project was to create a design. So basically we must be clear about the design, and we must be clear about what we need to do and how we need to do. So basically I started with a design, and then I made a study about the components. So there are, when we talk about drones and robotic arm, it is a developing, and it is a well known technology to everyone. So there are many advancement keep on going, and there are many new inventions uh, that can be added to the drone and robotic technologies. So there are many kind of components which can be used in the place of one another as their replacement. So we need to study about what kind of product and what kind of component we have to exactly use, so that we can achieve the more efficiency, and also we can achieve more responsiveness under the cost. So the flow of work includes the design phase and the study phase, and the assembly phase and also the testing phase. So I started with the design, and the design includes I structured the I designed the structure of the project using the CAD software, and then I made the study about the components that can be used in my project, so that the project can be easily affordable, and also it can be more efficient. And then the components were integrated. This is the assembly phase, and then the project is tested in the safe environment, because when we do a project we must be sure that the project is safe, and so we need a testing phase. So these are the components which these are the hardware requirements for my project. uh, these are the components used for drone. I used a BLDC motor. BLDC motor is nothing but a brushless DC motor, a flight controller board, propellers, a frame, electronic speed controller, remote controller, power supply, etc. And then when we talk about robotic arm, these are the components which I've used. These includes flex sensors, Arduino. As I showed in the block diagram, I show you Arduino Uno and as well as Arduino Nano. So there are two Arduino boards which I have used in the robotic arm, and then the gloves, and the servo motors have been used in the robotic arm, and NRF 24L01 module. This is a transceiver module which is used for communication, wireless communication between the robotic arm and the robotic gloves. So we can see about the we can see about the components in the component specification part. Software requirement. So the software required for this project is basically the CAD software, which is basically used for designing the structure of the arm, and then Arduino is used for the programming, basic programming in this model. So we can see the component specifications. As I said before, the second phase is the flow. In the flow of work is choosing the right components. Since the drone has been under development for so many years, there are variety of options available for the components we are intended to use. But the component should be wisely used wisely in order to be cost efficient, because we cannot use any other components which is very costly but the efficiency will be might be very low. So we must be very particular in choosing a component. When we choose a motor for a drone, there are many varieties available. uh, there are many kind of motors available in the market right now, so we must be very peculiar in choosing the components. So the motor should be low kV motors in heavy drones, and it should be a higher kV motor for a racing drones. So when choosing a motor, the kV of the motor we need to take care of many things. So one such important thing is the kV of the motor. So basically higher kV motors can be used in the racing drones. It can give us speed, but it will not provide us the lift picking capability. If we want our drones to be used for heavy lifting, we must be going for a lower kV motors. So this is the kV of the motor. This is why we have to look of the kV of the motor. And then the thing which is needed to be taken care when we choose a motor is the type of the motor. There are two types of motor available. Actually, there are many type of motor available. One of the type is that brushless motor and a brushed motor. In this project I have used a brushless motor. We go for brushless motor because it is easy to control, and it gives more efficiency, and it uses less power when compared to the brushed motor. That is why I've used a brushless motor here, and I have used a low kV motors in my project. And basically these components are studied only because to ensure safety and precision. And also the main factor when we choose a component is the power and torque. So we need to take care that the power which we use in that circuit is utilized properly. So when we use a brushed motor, it gets heated very fast, and it may use excess power, and the efficiency will be very low. So that is why we have to use a brushless motor in the drones. If we are using the drones for very limited purpose, or else if we are using for it as a toy, we can go for brushed motors. But if we are doing it for any purpose, actual purpose, then we have to go for brushless motors. So after choosing the motor, we have to choose the suitable electronic speed controller. So if we are working with brushed motors, there is no need for electronic speed controllers. But if we are going with brushless motor, we have to actually use a electronic speed controller. The electronic speed controller I have used here is a 30 amps electronic speed controller. It is basically used to control the speed of the motor. It basically decides the RPM of the motor, which at which speed it has to run, and when it has to run fast and when it has to run slow. We cannot blindly use the motor. We cannot blindly run the motor as fast as it can, because at some point we need the motors to be slow, and some point we need the motors to be high when we are using that motor in a drone. So we have to be using electronic speed controller in the flight. And the frame I have used in this project is a F450 model of the drone frame. And then the propeller I have used is a 1045 propeller, which has a 10-inch propeller with 45-degree angle. And then the brain of the drone is a KK 2.1 controller, which is the flight controller I have used here. The KK 2.15 is a flight controller, which is the brain of my drone, because with this all the operation of the drone is controlled. This flight controller has a Atmel Mega 664 PA IC inbuilt inside it. It has the inbuilt sensors. It has so many sensors within itself. It has MPU 6050. It has gyroscope and accelerometer. It can auto function, and it is a 8-bit AVR RISC based microcontroller with a 64K of memory. It has inbuilt accelerometer, gyroscope, and the 6050 MPU and auto level function. It has 8 motor output at the right side of the board. We connect ESC here, and it has 5 control inputs. These inputs are connected to the receivers. So when we can look at the board picture of the board in the upcoming slides. So there you can see that there will be the receiving pin and also the control pins. So there will be 5 control pins inputs. They will be connecting the receiver. They will be connecting the receiver. So it also has one LED display in the middle. It will work as a user interface for the drone. We will be setting the flight controller using that display. In its operating voltage is 1.8 volt to 5.5 volt, and its input voltage is 4.8 to 6.0 volts. So the other main component in this project is a transmitter and receiver. Here FSCT6B, which is a 6 channel transmitter receiver, is used, and it can operate at the range of 2.4 to 2.475 gigahertz. So it basically uses a AFHDS protocol for communication. The thrust of the each motor is approximately 800 gram, and hence the drone can lift the weight of 3 kgs approximately, in which the 3 kgs also include the weight of the drone itself. And the flex sensors and the servo motors have been chosen. So when we talk about servo motors, there are metal gears and plastic gears. I'm using a metal gear servo motor because it is more efficient, and we can also use the plastic gears, but it can be easily broken. That is why I go for MG90 servo motor. So principle of working. The main principle of the drone is the balancing. It has to balance. It has to maintain the balance of the system. One pair of rotors rotates in clockwise direction, and the other pair rotates in the anti-clockwise direction to make the drone fly into the air. To move up, all the rotors must run at a high speed. By changing the speed of the rotors, the drone can be moved forward, backward, and side to side. The movement of the drone are classified into four types based on the relation motion between the propellers. One is throttle, pitch, roll, and yaw. So when we talk about throttle is the motion which is in which all the four motors run at a high speed so that it can lift the body of the drone into the air. So the second motion is the pitch motion. In the pitch motion, the drone is moved either forward or backward. The forward and backward motion is called as pitch. And the roll motion, in the roll motion, the two motors run at slow speed, and the two motors run at high speed. It can either rotate in clock it can either rotate in the right side or in the left side. So the yaw motion, in the yaw motion, the diagonal motors are operated. So if the right diagonal motors are run at high speed, then the motor will rotate in the anti-clockwise direction, and if the motors in the other diagonal rotates in at high speed, it works in the clockwise direction. So this is of the basic working of a drone. So as I said before, the model is designed using the CAD software. This is the basic model of the drone, which is design of the drone, which is structured using the CAD software. So here, this image this image shows us the image of the drone, but when it is in the ground, because the arm is in this position, the arm is in this position, so that it can be used to do a work, and it can be used to do that task which we employ them into. And but the only disadvantage is that we cannot make this arm in this position when it is in the flight, because it the arm may interfere with the propellers, and it can disturb the flight. So that this type of structure is made, so in order to avoid the interference of the robotic arm during the flight of the drone. So this is the picture of the drone when it is in the flight. The arm will be in the vertical position when it is in the flight, and the arm will be in the horizontal position when it is not in the flight. So these are the components which I have used in that project. I have used a 4500 mAh power supply. I have used a lithium polymer battery. We can also go for lithium ion batteries, but lithium polymer batteries gives us more advantages when compared to lithium ion batteries. That is why I went to lithium polymer as the power supply, because it can hold the power for a long time than lithium ion. The lithium ion get discharged very easily. And I've used a 2212 BLDC motor. It is a 1000 kV motor, and which has 13 turns. And the propeller I am used here is a 1045 propeller. This is a 10-inch propeller. So as I said before, this is the flight controller board, the brain of our drone. So it has a 55 millimeter into 55 into 19 meter of size, and it weighs up to 32 gram. The IC uses a ADMEGA 644 PA, and it has inbuilt gyroscope, accelerometer, and a 6050 MPU. MPU stands for motion processing unit, and it can auto level. And also the input voltage for this flight controller is the 4.8 to 6.66 volts. It has 6 pins, signal from receiver, and it can also control many. It can also be controlled without the receiver, so we can integrate this flight controller without a receiver. We can make use of our laptop as the receiver. There will be a cable which can be used to connect the flight controller as well as this receiver. So this is the 6 channel transmitter. It has 6 channel, and the working range is 2.4 to 2.475 gigahertz. It has less than 20, the RF power is less than 20 decibels, and it uses the protocols of AFHDS, and the low voltage alarm is lower than 9 volts, and the power input is 12-volt DC supply. So this is the assembly of my drone, and the drone is assembled. In this assembly, the next is the assembly phase. So I have assembled the drone as per the block diagram. So these are the propellers. The propellers are connected to the motors. The motor are connected to the ESCs, and the ESCs are connected to the right side of the controller board, flight controller, and transceiver on the receiver side is connected to the flight controller as well. And this is the frame, and here I have attached the extension of this frame, because if we use only the F450 frame, then the height of the drone will be very less. We will be having less space here. So in order to increase this space, this height, I have used the extension. So this is the assembly of the robotic arm. So here I have used the Arduino Uno. The servo motors are controlled, connected to the Arduino Uno using this breadboard, and the arm is connected using a spring. The springs are used to regain the position of the arm very faster. So here the servo motors control the movement of the arm fingers. So this is the flight controller board. You can see here it shows the error message. When we turn on the flight controller board, it shows us this message. So basically it shows us self level is off, error, that no yaw input is given. So this is the basic message when you will be getting when you give the power supply to the flight controller. So we need to make changes using these push buttons. We need to reset the board, and we need to do certain settings to make the drone compatible. And here you can see that when you go into the menu, you can see the PI editor, receiver test, etc. There will be so many options available. We need to do the necessary settings before we have to configure the flight controller board. So this image shows us the configuring of the board. So next, the when we turn on the receiver and transmitter, we can see that when the transmitter and receiver is not binded, we will be getting as the all the signals will be no signal. Here you can see that all the values are no signal here. The elevator angle, throttle, everything is no signal. So we will be getting this kind of message when the transmitter and receiver are not connected properly. So when the transmitter and receiver are communicating properly, we will be getting the values of the angles. So we need to set it all the values into 0 before we starting the flight. We have to make the throttle in idle position before we give any value. So next, when the configuration is done, you will be getting this message as safe, self level is off, and okay, you can see okay here. So we will be getting this message when the drone is ready to fly. This message ensures that our drone is perfect for flying right now. So this is the final assembly of the drone. So this is the final assembly of the drone. Here you can see the armed. This armed signal is given when the transmitter and receiver communicates properly. Here it is a small demo of the project. So you can see the propellers running all at high speed. So this is during the testing phase. This video is taken during the testing phase. So this video shows us the working of the robotic arm. You can see here the arms are bending. The arms are bending using these servo motors. uh, these servo motors are connected to the Arduino board, which in turn makes the arm work. So this video shows us the entire project. You can see here the propellers are running. So since it is in the indoor, the throttle is not given at high speed. Just the motors are run to show that the drone is ready to fly. Here you can see that the robotic arm is working. The robotic arm is working using the servo control. This video shows us the working of the arm only. So this is the robotic glove. This is the robotic glove I have used, and here these are the flex sensors. The motion of this robotic arm is based on these movements. So that's it. This is my project. So thank you one and all for your patience.